Assalamualaikum and selamat sejahtera. Today we're going to start with chapter 8, lesson 8, chapter 8, rotation of a rigid body, where this chapter you have 4 subtopics. Okay, we're going to look at the first subtopics where we have rotational kinematics. First, define and use angular displacement, average angular velocity, instantaneous angular velocity, average angular acceleration, instantaneous angular acceleration. Next, we're going to relate the parameter in rotational with their corresponding quantities in linear motion and solve problems. Okay, overview, what are we going to learn in chapter 8? The first one is under rotational kinematics, we have to relate with the linear and rotation with uniform angular acceleration. Next, equilibrium of a uniform rigid body. We're going to learn about torque, where torque equals to R cross F. And the conditions for equilibrium is when the total of F equals to 0 and total of torque equals to 0. Third, rotational dynamics. We're going to learn about moment of inertia, where the formula is summation of torque equals to I alpha. And the last part will be conservation of angular momentum, where we're going to learn what is angular momentum and the principle. Okay, start first subtopic 8.1. So angular displacement is defined as an angle through which a point or line be rotated in a specific direction. So angle rotated in specific direction. So consider a point P on a rotating compact disc, move through S along a circular path of radius r about a fixed point. This is what we have learned in chapter 6. Okay, circular motion, rotational motion, where the formula is we have theta, angular displacement, equals to S over r, or S equals to r theta, where theta is our angular displacement in radian, the SI unit, S is arc length, so, and R is radius of the circle. SI unit for angular displacement is radian, but your theta can also be represented in terms of degree and revolution. One revolution, so one complete cycle, you have 2 pi radian, which is equals to 360 degree. Sign convention of angular displacement. So first, if your object rotate anti-clockwise, so your object rotate anti-clockwise, so your theta is positive. But if it's rotate clockwise, sorry, the other way around, when it's rotate anti-clockwise, so anti-clockwise, this is your theta positive. But then when it rotate clockwise, so this is your theta equals to negative. Angular velocity, again we have learned this angular velocity in chapter 6. So angular velocity is defined as rate of change of angular displacement, where we can relate with linear velocity, v equals to s over t. So for omega, average omega will have rate of change of angular displacement delta theta over delta t, where theta 2 is final angular displacement, theta 1 is initial angular displacement, and delta t is your time interval. So you have two. First is average and second is instantaneous. So for instantaneous velocity, v equals to ds per dt. For instantaneous omega is defined, so your instantaneous angular velocity is defined as instantaneous rate of change, where you have differentiation of theta with respect to t. So d theta per dt. Angular velocity is a vector quantity. The SI unit, this is your SI unit is radian per second, but can also be expressed in terms of revolutions per minute or revolutions per second, where 1 revolution per minute, when you want to convert into radian per second, So 1 revolution is equals to 2 pi radian, and your 1 minute is equals to 60 seconds. So when you want to convert into radian per second, you have to times with 2 pi over 60. Okay. Direction of angular velocity. How to determine the direction of angular velocity? We can determine using right hand grip rule, where first you're going to curl your fingers. So this is the first one. You curl your fingers to the direction of the rotation. Then your thumb is the direction of your angular velocity. So example, when you have your direction of rotation anti-clockwise, so you can see this is the direction of your angular velocity, this is the other way around, then you will have opposite angular velocity direction. Third is angular acceleration. Again, angular acceleration also will be divided into two, average angular acceleration and instantaneous. So A equals to V over T. For alpha, angular acceleration, the symbol is alpha. Alpha, the equation will be delta omega over delta T. And the instantaneous angular acceleration will be differentiation of omega per T. So it is rate of change of angular velocity. For instantaneous, you have to differentiate your angular velocity with respect to time. Angular acceleration is a vector quantity and the unit is radian per second squared. Okay. Direction of angular acceleration. So, you need to know, okay, if your rotation is speed up, which means your A and omega same direction. Okay, so if the rotation is slowing down, then your A and omega opposite direction. Okay, kalau slow down, so your alpha and omega opposite direction. When it speeds up, your alpha and your omega same direction. How do we relate between V and omega? So, as per chapter 6, you know that S equals to R theta, V equals to R omega, where the direction of the linear velocity always tangent to the circular path here. Linear velocity is the tangent of the circular path. Every particle has same angular speed. Okay, angular speed same, but the tangential speed is not the same because of radius changing depends on the position of particle. So, it depends on R. Kalau dia sama, then constant. Tapi let's say next, you're sampai sini je, then it will be different. So, it depends on R. If the angular speed of the rigid body change with time, either it's increase or decrease, the angular acceleration is produced. When you have different in angular velocity, either the magnitude or change in direction, so you will have alpha angular acceleration. Angular acceleration can be related with your linear acceleration is by using your linear acceleration A tangential equals to R alpha. So you have your linear R theta, V equals to R omega, and your A equals to R alpha. Okay, A equals to R alpha. So this is your linear times with R, and this is your rotational quantities. Okay. So here you can relate between your linear and rotational as dia punya kawan dia theta, U omega naught, V omega, A alpha T same time. Then this is the relation between your linear and your rotational. Okay. Then from the linear motion, okay, where you have V equals to U plus AT, so for rotational, you just have to change your V into omega, U into omega naught, A into alpha. S equals to UT plus half AT squared, it will be, so your S is theta omega naught T plus half alpha T squared. V squared equals to U squared plus 2AS, it will be omega squared equals to omega naught squared plus 2 alpha theta. Basically, all A will be alpha, all S will be theta, all U will be omega naught, all V will be omega, but T will remain constant as T. Okay, T same. Okay, this one, okay, these three quantities later we're going to look at, where mass, the rotational motion that related with mass is moment of inertia, I. Your momentum P equals to mv will be angular momentum, L equals to I omega. Okay, so basically your P will be L, mass is I, V is omega, and one more, total of force equals to MA will be total of torque equals to I alpha. We're going to look at all this in 8.2 until 8.4.